Currently available PWM charge controllers can sense battery voltage and set up charging voltage accordingly. That is why it is mentioned that battery should be connected to the charge controller before the solar panel. When a 12-volt battery is connected to a PWM charge controller, it will force the 24-volt solar panel to work as if it is a 12-volt panel, which will in effect waste about 50% of its potential. An option to avoid this wastage is to use a buck converter between the solar panel and the PWM charge controller to give about 18 volts to the PWM charge controller. But that will have to be meticulously set up in the buck converter. Buck converter should have a maximum voltage rating of at least 60 volts. The commonly available buck converters can take only up to a maximum of 30 to 40 volts. 24-volt solar panels will have an open circuit voltage of 45 volts and more. Current rating of the buck converter should match the power rating of the solar panel. Better and safer option is to replace the PWM charge controller with an MPPT charge controller. Though the MPPT charge controller is more costly, it will take care of all these issues as a one-shot solution. The solar panel will work at its maximum efficiency. Then your battery should also have the capacity to utilize the extra power available. I learned all these the hard way after buying a 24-volt solar panel without knowing that it is 24 volts and not 12 volts. I did lose a couple of buck converters as well. Now I am on the lookout for an MPPT charge controller which does not produce radio frequency interference in my high frequency or HF ham radio. Many of the MPPT charge controllers and inverters produce a lot of noise in the HF bands, preventing good reception of relatively weak amateur radio signals.